The first method we are going to consider is using the solve function. And for using the first method, we have to use this symbolic variable to define the four variables in the equation. So using syms, we have four variables which are w, x, y, and z. And then I have to define my equation. So for equation 1, let me call it eq1, and it will be equal to w plus 2 times x plus 3 times y plus z is equal to 2. So for the quality, I have to use double equal sign. Now I have my four equations. So let me call my solution. Let me define my solution as sol n. So it will be, I will have to use the solve function as I said. So you can give it three arguments, but the first two arguments are the crucial arguments. So the first one is your equation. So if you have like one equation, then it will just be a scalar. But if you have like more than one equation, it will be defined in vector form. So we have like more than one equation, that is four equations. So we have to define them as a vector of equations. So the second argument is your variables. Also, it is not a single variable. We have four variables, so we have to define it as a vector. So for the first argument, as a vector, I will have equation 1. I can separate them by comma or by space. Anyone is okay. So equation 2, equation 3, equation 4, then comma, then I have to define my variables, which are w, x, y, and z. Just run my m file. So after running it, as you can see, I have solution is equal to a struct field with my variables w, x, y, and z, and the solution are 5, 4, -2, and -5 respectively. So you can have them like specifically by just defining w is equal to sol n time dot w, comma. So if I run it, you'll see that I will have my w. You see I have my w is 5, x is 4, y is -2, and z is -5. So the second method we are going to consider, let me just write it. I will have my second method is using the linsolve function. For that method, I also need the definition of my symbolic variables, and I also need the definition of my equation. So I have my four equations. For the linsolve method, it requires you to represent the equation in form of matrix, that is ax is equal to b, where a is the coefficient of your variables, is a matrix containing the coefficient of your variables, and b is a matrix containing the coefficient of your constants when moved to the right hand side. So I have my equations. How can I obtain my a and b matrix? So I can easily do that by using the equation to matrix function. So I will just have my a matrix and b matrix. I will just put my equations to matrix. So I have my equations, equation 1, equation 2, equation 3, and also equation 4. And then the second argument is also the variables. So I have w, x, y, and z. So this will give me a and b. Then I can obtain my solution in form of just linsolve. Then I will give it the determine matrices. So after running it, so I will have my solution. As you can see, my w is 5, my x is 4, my y is -2, and my z is -5. So the third method So you can just define your equation in matrix form. So I just have to define my A. So I have 1 2 3 1 as the first equation. So A will contain the coefficients of the unknowns. So 1 2 3 1. Then I move to the next equation. So that is the first matrix. And for the second matrix, I will have B is just equal to 2. Then move to the next row. I will have 1 to the next row, 5, and then 2. So my X will just be A inverse times B. So how can I achieve that? So let me just define my capital X. It will just be inverse of A times B. So let me clear my command window, and if I run this equation, as you can see, I have my X is equal to 5, 4, minus 2, and minus 5. Alternatively, so this basically means B over A, and if you run it again, it will give you the same solution. So 5, 4, minus 2, and minus 5.